First let us start with periodic and aperiodic signals. A signal x of t, any given signal x of t, is said to be periodic if it satisfies the following condition. What is the condition is, x of t should be is equal to x of t plus capital T. This capital T is called as the fundamental period of the signal. So if this condition is satisfied, then the given signal is said to be a periodic signal. According to the definition, any signal which repeats at regular intervals of time is called as a periodic signal. So this signal x of t, if it is equal to x of t plus t, as I said, it's a fundamental period capital T. It could be t, 2t, 3t, 4t, so on like that. So any signal which repeats at regular intervals of time is called as periodic signal. Similarly, for discrete signals, whatever the formula that is in blue color here is for continuous in time signals, and for discrete signals, condition is x of n is equal to x of n plus capital N. This capital N is again the fundamental period of a discrete signal. So let us take a small example. Consider x of n is equal to cos 2 pi f n. So let us see whether this signal is periodic or not. If it is periodic, then what is its fundamental period? How to find out the given signal is periodic or not? For that, we took this example. So cos 2 pi f n, according to the definition, this one is equal to cos 2 pi f of n plus capital N, because the given signal is discrete. So I took the second formula. So cos 2 pi f n is equal to cos 2 pi f of n plus capital N. So if we expand, it will become cos of 2 pi f n plus 2 pi f capital N. So in order for the above equation to be true, the above equation is satisfied only if this term 2 pi f n is a multiple of 2 pi. If it is an integer multiple of 2 pi, then it is said to be periodic. I mean, this above equation will get satisfied if this term is a multiple of 2 pi's, integer multiple of 2 pi's. So that's why I wrote 2 pi f n is equal to 2 pi k, where k is an integer. This 2 pi is an integer multiple of, so I took k, which is an integer here. Now this 2 pi and 2 pi will get cancelled, and we will get f is equal to k by n. F, we already know, it's a frequency of the given signal, cos 2 pi f n. In that, f is the frequency. So this frequency, if it is in the form of k by n, then the signal is said to be periodic. Similarly, for CT signals, if frequency is in the form of k by capital T, then also it is said to be periodic. So a condition for periodicity, if a given signal is of the form cos 2 pi f n or sin 2 pi f n, then it is the frequency of the signal should be in the form of p by q. It should be in the form of k by n for DT signals and k by t for CT signals. Thus the signal is periodic if its frequency is rational, if it is a rational number. So let us see for other case also. If the signal is a combination of two, x1 and x2. So in this case, x1 is a signal whose fundamental period is t1, x2 is a signal whose fundamental period is t2. So the overall fundamental period of x of t is LCM of these two, t1 and t2. So we will call the overall fundamental frequency of the signal x of t as capital T, and this is t1 and this is t2. So you can look at that one. x1 of t is equal to x1 of t1 t plus t1, because it's a periodic. I am taking the condition x1 of t1 t plus t1, or it could be t plus t2, or it could be t plus 3t, so on. Actually this is 2t, not t2. Two t1, next 3t1, 4t1, so on like that. So I will summarize it like this. So x1 of t, if it is equal to x1 of t plus mt1, then the signal is said to be periodic. Similarly, x2 of t is periodic if it satisfies the condition x2 of t plus nt2. So overall, the signal x of t will be periodic if it satisfies this condition. mt1 is equal to NT2, MT1 is the fundamental period of this signal, NT2 is the period of second signal. If both are equal, then that should be equal to capital T. Capital T is the period of x of t. So from that we derived the t is integer multiples of periods of both signals, x1 of t and x2 of t. So I wrote it, one is m into t1, others n into t2. So from that we derived a condition t1 by t2, the ratio of the two frequencies, t1 of the first signal, t2 of the second signal, if it is in the form of n by m, then the signal is periodic. Similarly, if the signals are dt signals, the ratio of n1 by n2, if it is in the form of n by m, then the signals are periodic. So here we have seen what is a periodic signal, the definition of a periodic signal, and the condition for this type of signal. Frequency should be in the form of p by q, it should be rational, and if the combination of the signals are given to us, then the condition is ratio of the frequencies t1 by t2 or n1 by n2 should be again rational, it should be in the form of n by m. So like that we can find out whether the given signal is periodic or aperiodic with the help of this explanation. So this explanation will help us to solve, or will help us to identify whether the given signals are periodic or not.